Hello everyone, this is Caplitero and welcome back to a new episode. Today we're gonna talk about 3D perspective, 3D objects, and we're starting with uh, triangles because 3D objects are composed of triangles, many triangles, and today we're gonna talk about how those triangles are created. Last time we made one cube, but cubes are not so useful, so we're going with triangles today. Like usual, we're gonna create a oops, down. Um, let's call it triangle. Create and let's get started. I'm gonna create a new header file. I'm gonna call this triangle class. Add in this triangle class we're gonna add um namespace because name space cap because in my videos identify name space because I normally use one structure and it's a 3D vector. You guys know this vector very well. Coordinates x, y, z. See, this is a constructor. If initialized, will put 0. If we want to construct a default vector, custom vector, we input x, y, z. And these are some functions. This will calculate distance between one position to the other. I don't have include the stream. I'm gonna use your stream some all the times. Here I forgot to add this part of the structure. And those operators are, if we normally had, let's say, one vector plus vector, what will this result? Well, you can see right here, if we input this operator, it will calculate and add vector x, this x, plus the x of this one, and return a vector composed of those. Now we're gonna create the class triangle, triangle, and you know the rotation. We're gonna use those again, but for now, I'm gonna go to public, and we're gonna have three important not variables. Vector 3D of origin. This will be the origin of the vector. Normally it's 0, 0, 0 in the corner left, or depending on the engine, it can be in the middle of the screen. Next, we're gonna have vector 3D of center. This will be the center of the triangle. And then we're gonna have a array corners. A triangle has 3 corners, so we're gonna have 3 of them. We're gonna have a constructor, but we're gonna have an update because we are gonna change the points of the triangle outside. So we're gonna implement this, we're gonna change the corner outside, let's say in the window class. And after we've done that, we're gonna update it. And what are we gonna update? Gonna do the center, vector 3D of, well, this was the center. Well, center of mass, and by doing that, it's gonna create a cube, a cube. I meant to say a sphere with the distance from the uh let's, because I use paint all the time. Let's say we have a oh, I actually have this. Let's say we have a triangle, and we're gonna go like this to the middle, this and this, and this point will create a sphere. We can rotate um, the points, the corners corresponding to this point. And how we're gonna find that? It's we take the, let's say, the position of x1, oh, x1, x1, x2, and x3. Add these together and divide by 3. This is uh, this will be used for all the positions, so x, y, z, and I'm gonna open this like this. Um, no, this, and yeah, corners, corners. Oh, we have the first corner, second, and third x divided by 3, I, 3, and now we've updated our center. Um, Now we're gonna find some translations. What is a translation? So let's say that we want to move this point around. So let's say I want to move it here. Well, I can't do that because rotation goes, the point goes uh, around the region. I told you a few moments back that origin will be 0, 0, 0. And how we do that? Well, if this point will always be, let's say, alpha, alpha distance from the center, we know that we can move the center to the 0. Well, if we move the center to the 0, this will also move, but we go from 0 to this distance. So we'll call this translation. So how we do that? Well, the distance from this to this point is actually, let's say, x1 minus x4. This is the distance between points. And if we go to 0, we'll see that this will be, let's say, alpha will move here. Here's the middle, and x will go at this. So this will actually also be alpha. So we do that? Well, pretty simple. We're gonna iterate through all I mean all. There are two of them, but yeah. And we're gonna have translation. We can actually put it right here. No, here. I'm sorry. Vector 3D translation of 3, and translation of I equals corner minus center. So we're gonna find the distance from this point minus the center. Now gonna let's add some functions. Let's say that we wanted to move float x, float I, float. Let's say you wanted to move this one, the object, um, the triangle with a small percentage to the right or left, and that vector 3D x, I, z. We're gonna move this by this amount. I'm gonna call move. I did not write what move is, but it will be a separated function, especially for this, because it will go through the points and every corner will position will be changed. Center, so we'll say I want the new corner coordinates to be this, and let's say I want to add a alpha, the translation, and I'll get a new point. If the point was here, the alpha will be moved here. So we're adding alpha translation. Oh, this is move. This is a special move. Let's add void resize float alpha. This will resize the object by the amount you want. Let's say I want to double it, so alpha will be doubled or 2. Translation false alpha. And now we move will be transform. So let's call this transform. Let's go here and call this transform. It will be useful for you guys. And one more thing we can add, it's the rotation. Well, you guys already know the rotation from the cube episode if you watch it. But in mathematics, there is a way of rotating circles around the 0, 0 axis, the x, y axis. But for that, we want to make a axis, and let's say we want the triangle will be here, but we'll translate it here, and now every point will be rotated, let's say by an x and let's say by an alpha value. So we're gonna rotate it. After that, we're gonna save the points, and the triangle will be put again in his position with the new uh with the new rotation. I don't know how you rotate. Oh, let's say by this. Was supposed to be in the other way, but you know what I mean. So, transform was the problem. Corners. Oh, wait. Expected a wait. The problem. Transform. Oh, it's missing one here, here. Oh, right here. Yeah, missing just one bracket can mess up your code. Corners, corners. Now, this is the translation. So we're not moving the point here. We're moving its translation around the X and Y axis, X and Y. The rotation on the X means the plane X. So we're not including X here. We're moving Y and Z, and transform. Wait. Okay. Transform, transform. And right here, we're gonna have the rotation alpha x, the rotation for x, y, and z, the way we want to move this transform. Anything else? I don't think so. So we have the rotation, resize, move, update. We have the move, the transform, rotate z, and this is all. So now we're gonna go in here, load triangle class, app triangle, let's say, okay. I have right here a small notepad. First of all, what is most important, don't set your frame limit too big for the application. Set it to your refresh rate. I use mine. You can go higher, but don't leave it blank because the games don't work the way you want at higher of FPS. We're gonna add the corners. So triangle, triangle. We set the triangle coordinates, and after we've changed the coordinates, we have to update to find a new corner and translations. Now we also want a SF vertex array. let's say, um, vertex array, because why not? The vertex array will be set primitive, will have a set triangle, and vertex array will be resized to 3 because we only have one triangle. Let's also add some color to the corners. I'm gonna copy this. Hmm. What else? Vertex array. Okay. And let's say here in update, we're gonna update our triangle. So let's say we want to move the triangle. Let's rotate it. So I'll show you. On the x-axis, yeah, let's go on the x 0.0100 and rotate no for int I0 I smaller than 3 because we have 3 corners. Vertex array I position equals a vector to f of triangle in corners with corners I x, copy this, and we're gonna have y, and we're gonna clear and draw into draw vertex array. We can add different positions, but let's see how this works. We're not having problems for the first time in ages. Let's wait for the compiler. SFML compiles very slow. And you can see it goes up. Let's say I wanted it to move to the right 0.1. X goes that way, Y goes this way. Whoop. This is what I've told you about FPS because too many FPS frames per second and your game goes numb. You see it's moving everything, and we can actually move the triangle too. Let's say move by, let's say I wanted to move to the right 1 0 0. Actually I want to go down too. What's the problem? I added this. And you can see that it is going It's rotating and going down, down. So everything is working. You can do everything you want with this. And it's not a lot. I spend a lot of time explaining, and that's why the videos take so long, because I could just post the uh the code, and if that's all. But I want to explain for myself and everyone, because maybe in the future I forget what this does, and I want to re review review my knowledge. Yeah. So hope this was useful. It's not only for SFML. You can see that the only thing we do with SFML is draw. I mean, any other calculus, yeah, algebra is done by triangle class, and the only thing, the coloring, because it's a shader. I think, DirectX and Novel, can you have to do it yourself, but usually those are already done. And I'm just trying to show you guys. I'm not trying to create my own engine or API, or I don't know. I'm just trying to see how everything is working in 3D, how games are done, and I'm trying to do something interesting for the next video. So uh, just wait, just wait, and you'll like it. Once again, I thank you all guys for watching me. Maybe click a like, subscribe, and see you next time.